All right, guys, welcome to class. We're going to be watching some videos here. So I would like for you to go to your email and make sure that you have the notes packet downloaded and that you've moved it to Notability so that as you watch this video, you can take notes along with me. If at any point I'm going too fast for you, just make sure you pause it so that you can copy down what you need, and you can always go back and rewatch parts if you need. So, as you can see from the title page, we are going to be starting a unit here on square roots. So today we're going to do basically an introduction to square roots. We're going to talk about what is a square root, what's a perfect square, how do we find square roots, how do we solve or simplify expressions that have square roots, and solve equations that require square roots. So we're going to kind of cover a lot today, and all these skills that we're looking at today we are going to use in future lessons as we start applying square roots to different situations and seeing how we can use them. So let's start by filling in some blanks here. So follow along with me as we go. So a square root of a number n is a number m such that m squared equals n. So every positive number has two square roots. One square root is positive and the other is negative. The radical sign, which looks like that, so we call it a radical sign or a square root sign, that means the same thing, represents a non-negative square root. The other symbol that we're going to be looking at is a plus sign with a minus sign right under it. And this is read plus or minus. And it refers to both square roots of a positive number. 0 is the only number that has one square root, and that is itself, and that's because there's not positive or negative 0. All right, let's try to explain this a little bit more. So first of all, what is a square root? Well, because 4 squared equals 16, for example, we would say that the square root of 16 is 4. In other words, when we're finding the square root of a number, we're asking what number times itself would equal that. Let me give you another example. 6 squared, for example, is 36. So the square root of 36 would be 6. All right, now when it's talking about this idea of how a square root has a positive and a negative, here's what we mean. Think about this. What is negative 4 squared? Well, we know that a negative times a negative is a positive. So negative 4 squared would be negative 4 times negative 4, which is also positive 16. So because 4 squared is 16 and negative 4 squared is 16, we can also say that the square root of 16 could be negative 4. And that's what it says, that every positive number has two square roots. So when we're giving the square root of 16, you can either say that is 4 or negative 4, or here's where that symbol comes into play. You can say it is plus or minus 4. That would be the positive and negative of 4. If we go to our example of 6 squared being 36, well, we also know that negative 6 squared is also 36 because a negative times a negative is a positive. So the square root of 36 could also be negative 6. And so we would say that the square root of 36 is plus or minus 6. All right, now this also talks about how the square root has to be positive, or in other words, it says a non-negative. In other words, it's not a negative number. And we're not going to get into this super in detail, but I do want you to understand this just a little bit. The square root of negative 16, think about that for a minute. What number times itself could give us negative 16? The answer is nothing, right? Because the way you would get 16 would be 4 and negative 4, but that's not the same number. And so this does not exist in our real number system. That would be what's called actually an imaginary number, which we're not going to get to in detail. But what you need to understand right now is that you cannot take the square root of a negative number. That does not exist. All right, so let's move forward and start using some of these square roots. All right, so this first example actually has us doing a little bit of area. It says a community is building a playground on a square plot of land with an area of 625 square yards. What is the length of each side of the plot of land? Well, we need to remember a little something about area. So this is a square, which means we know all the side lengths are the same. So we could say it's length times width, or because the sides are the same, we can say that it is side times side. Or we could write that as side squared. So that's how we would find the area. And we know, so if the area is side times side and the area is side squared, well, the area is 625 yards squared. So what we're trying to figure out here is what number times itself would give us 625. Now, eventually I'm going to teach you how to use your calculator to find a square root. But for right now, maybe let's do a little guess and check. So I don't know, let's start with 15 times 15. All right, that gives me 225, so that's not high enough. Let's go 20 times 20. Well, we should know that's 400, still not high enough. How about 25 times 25? Ooh, there it is. So I know that if I need to multiply something by itself, the way I could get that is that 25 times 25 is 625. So the side length would have to be 25. Now, we just talked about how it could be a positive or a negative, like the square root of 625 could be positive or negative, but we know that distance can't be negative, and so therefore this would have to just be 25 yards. Now, we're going to look at equations in more detail in just a minute, so we will get that figured out in even more detail. But for right now, you could see that we could find the side length by figuring out what number times itself would equal the area. All right, let's find a few more square roots. So down below here, I've given you just some more simple numbers. So what's the square root of 16? Well, first of all, in the directions, it gives you a clue. It says find the square roots. All right, here's our little English lesson. That is a plural word. So that means there has to be more than one. All right, so what are the square roots of 16? Well, the square roots of 16 would be plus or minus 4. The big mistake people make is they just say it's 4. It is not only positive 4, it could also be negative 4. So the easiest way to write that is with the plus or minus sign. It would not be wrong if you put 4 or negative 4 like that. You could also write it that way. It's just a little quicker to use that plus or minus sign. All right, 64. What number times itself is 64? Well, that would be plus or minus 8. All right, how about 144? Well, you might not know this one. You could start typing things into your calculator, or now would probably be a good time for me to teach you how to use your calculator to find this. So if you're using the calculator that we've been using all year in class, here's what you're going to do. Look down the left-hand side, and do you see the x squared button? Right above that x squared button, you should see our radical sign or our square root sign. So remember, to get the symbol that's above the button, we hit the second button in the top left corner, then the x squared button, and you should see the radical sign. Now type in your number and close the parentheses. So I'm typing in 144 and closing the parentheses, and it shows me that it's 12. Now I have to be smarter than my calculator to know that it's not just 12, but it could also be negative 12, so it's plus or minus 12. Let's try that now with 256. So hit the second button and then the x squared button, type in 256, close the parentheses, and we get 16. So the square root of 256 would be plus or minus 16. All right, now if you notice, all of these came out to nice, pretty numbers. I want you now to type into your calculator the square root of 10. Ooh, that one didn't come out so pretty, right? And that's because there is no whole number times itself that equals 10. So these ones that we just found, 16, 64, 144, 256, they have a special name. They're called perfect squares. And they're called perfect squares because there is a whole number that we could multiply by itself to get to those. There are an infinite amount of perfect squares, but there's also an infinite amount of not perfect squares. And that would be like 10 or 12 or any number that does not have a whole number that you can multiply by itself to get to it. So let's turn the page now and write the definition of a perfect square. All right, so go ahead and pause the video for a second to get down this definition that a perfect square is a number that is the square of an integer. Down below, you see a chart that says need to memorize. Really, it just means the more familiar you are with the perfect squares from 1 to 15, and really even more specifically 1 to 12, the easier this whole unit will be for you, and you'll understand that more in the coming days. But what you need to understand here is that we're not saying that 6 is a perfect square. We're saying 36 is the perfect square because it is the square of the integer 6. So it's all of these numbers, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. Those are all perfect squares, and obviously they can continue on 16 squared, 17 squared. All of those would be perfect squares as well. All right, so what if it is not a perfect square? What if we need to find a square root of a non-perfect square? Well, there's two ways we can do it. One is we can use our calculator, and we'll practice that more in just a minute, but we can also approximate it. In other words, we can say what nearest whole number it would be to. In other words, what of the perfect squares would be around it. So let me show you how we'll do this, and make sure you write down this work exactly as you see it here. Okay, so the square root of 51. Well, if you type that into your calculator, you'll quickly see that 51 is not a perfect square because there's no whole number or no integer that multiplies by itself to get to 51. So we need to figure out what are the perfect squares closest to 51, and this is where the chart above you would help. Okay, so 49 would be the closest below it. I'm going to write this as an inequality, so I'm going to say 49 is less than 51, which is less than 64. In other words, 51 would fall between the perfect squares 49 and 64. Now I'm going to take the square root of all of those. Well, the square root of 49 is 7. The square root of 64 is 8. So we know that the square root of 51 would be somewhere between 7 and 8. Well, because 51 is closer to 49 than it is to 64, we would say that our final answer is that the square root of 51 is approximately 7. We can't say it equals 7 because it's not equal to 7. It is approximately 7. That is the whole number that it is closest to. So remember, we use those squiggle equal signs, and that shows that it is approximately. And when you're doing your homework, this is how you could write your answer. The sentence down below just explains what I just said, but you don't need to write that whole sentence. You can just say the square root of 51 is approximately 7. All right, so let's try a few more of these. All right, so 125, if you were to type that into your calculator, you would see it's not a perfect square, so let's figure out what it goes between. Well, use that chart above if you want, and I know that 121 would be the perfect square below it, and 144 would be the closest perfect square above it. So I'm going to take the square root of all of those. The square root of 121 is 11. I don't know the square root of 125. That's the whole point of this problem. The square root of 144 is 12. Now, I'm going to look, and 125 is closer to 121 than it is to 144. So my final answer is that the square root of 25 is approximately 11. And this is exactly how you need to show your work as well. Now, if you want to check it with your calculator, you can click second x squared to get that radical sign. type in 125, and you should see that you get 11.180333989. That's going to go on forever, but if you were to round that to the nearest whole number, it would be 11. We know that the square root of 125 falls between 11 and 12, but is closer to 11 because 125 is closer to 121. All right, why don't you pause the video right now and try 2 and 3, and when you're ready to check your answers, press play again. All right, check your answers with mine. The square root of 28 would be between 5 and 6, but since 28 is closer to 25, it would be closer to 5. And the square root of 60 would fall between 7 and 8, but since 60 is closer to 64 than to 49, we know that the square root of 60 would be closer to 8 than to 7. All right, so in the last examples, we approximated a square root to the nearest whole number. And we don't need a calculator to do that. But sometimes we want to be even more precise. And so this time we're going to round. It says in your directions to the 10th. Cross that out and put 100th. We always round to the nearest 100th. So let's go ahead and stay consistent there. And that's what you'll do on your homework as well. You'll round to the nearest 100th. And if we want to round to the nearest 100th, that's where we need our calculator. So you're going to do exactly what I showed you before. So you're going to take the square root of 636. You're going to hit second x squared to get that radical sign. Type in 636, close the parentheses, and you're going to say that the square root of 636, now you're still using the squiggle equal sign because we're still rounding, we're still approximating. This number actually goes on forever. It's called irrational. We'll get to that eventually. But right now you just need to round to the nearest 100th. So this one would be 25.22 because that 9 rounds the 1 up to a 2. Let's try the square root of 515. So the square root of 515 would be approximately 22.69. Again, these should be really easy because you're just typing them into your calculator. Now, notice on number 2, we see that negative sign. So technically in all of these, the square root of 636 should be plus or minus 25.22. A lot of times we're going to just look at the positive roots because one of the main applications we use of square roots is distance, and distance is always positive. So it's okay for you to give just the positive root unless it asks you for the negative root like it does specifically in number 2. The only time that you have to put the plus or minus sign, that you have to show both roots, is if it specifically asks you to find the square roots, like it did on the first page of our notes. And I'll give you a hint on your homework. The first, I think it's 6 to 8 problems, it will ask you find the square roots. And those are the ones that you have to put the plus or minus sign on if it asks you for both roots. Okay, but on this one, you're going to type into your calculator the square root of 104. Don't put the negative sign yet. And you see that it's 10.2 because that 8 rounds the 9 up, which then rounds the 1 up. So the negative root of 104 would be approximately negative 10.2. So if it has the negative sign in front of the radical sign, you're just going to put a negative sign in front of your answer. You're going to give the negative root of that. And I should have mentioned in the last section, there will be some on your homework that when you're approximating, ask you for the negative root. You do it the exact same way, basically figure out as if it were positive, and then just your final answer should have that negative sign with it because it's asking you for the negative root instead of the positive root. That's really all. All right, let's move on and talk about radical expressions now. So quick review, an expression is something that does not have an equal sign, so we can either simplify or evaluate an expression. So a radical expression is an expression that involves a radical sign. And remember that a radical sign is just another name for the square root sign. So a radical expression is one that has a square root sign. The horizontal bar of a radical sign is a grouping symbol. Now, we've talked a lot about grouping symbols. Remember, grouping symbols come first in order of operations. It's like a parentheses or the fraction bar or the absolute value bars. So that's why it really does matter how far the square root sign extends, because everything under the square root sign has to be done first. So when you evaluate an expression, a radical expression, you will evaluate the expression under the radical sign before finding the square root. Okay, and I think that after we do a couple examples, that might make even more sense. But just like when we did absolute value equation or expressions and you had to solve what was inside the absolute value bars and then take the absolute value and then do anything outside, it's the same here. You need to evaluate what is under the radical sign or under the square root sign, then take the square root and then do anything on the outside. So here's our first example. Evaluate 5 times the square root of a squared minus b. All right, so just as always, the first thing we're going to do is we are going to plug in a and b. All right, so this is 5, and remember when there's no operation, we know that's multiplication. So 5 times a is 6, so this would be 6 squared minus 27. Okay, so we need to first do what is under the radical sign. Under the radical sign, I have an exponent and subtraction. So I'm just following order of operations, and I know exponents come first. So 6 squared would be 36. And then I'm going to do 36 minus 27, and that is 9. Then I'm going to take the square root of 9, which is 3, because 3 times 3 is 9, and then 5 times 3 is 15. And again, here's another good example where it's okay to just take the positive root. Technically, the square root of 9 is plus or minus 3, but you can just take the positive root as we're practicing these. You only have to give both roots if it specifically asks for that. All right, let's practice some more. So in these, a is 16 and b is 9. So again, the first thing we do is plug in a and b. On number 1, remember when there is not a number there, we can always add a 1. And I'm going to do that just to make it a little more clear. I'm going to make this negative 1 times the square root of 16 plus 9. Again, this really is just asking us for the negative root instead of the positive root. So I first have to do what is under the radical sign, which is 16 plus 9, that is 25. Then I take the square root, so the square root of 25 is 5, because 5 times 5 is 25, and negative 1 times 5 is negative 5. So why don't at this point you pause the video real quick, try 2 and 3, and then press play to check your answers. All right, go ahead and check your answers with mine. Notice on each of these that I did what was under the radical sign, following order of operations, then took the square root, then did anything that happened to be on the outside. All right, the last thing we're going to talk about in this lesson is solving equations where we have to use a square root. Okay, now before we jump into equations, let's do a quick review about inverse operations. When we've solved equations in the past, we've talked a lot about inverse operations, and remember we've talked about how addition and subtraction are inverse operations, multiplication and division are inverse operations, and they're inverse operations because they undo each other. Well, today we're going to learn about another pair of inverse operations, about things that undo each other. And that is that taking the square root of something that is squared equals whatever that something is. In other words, squaring something and taking the square root are inverse operations. Let me try to show you with an example. Okay, think about this. 5 squared is 25. The square root of 5 squared, well, 5 squared would be 25, and the square root of 25 is 5. So do you understand that the square root of 5 squared is just 5? In other words, taking the square root of something and squaring it undo each other. Okay, now that's going to be important to us as we solve equations here. So you see a word problem in your notes. Then, if you could down below add these next 3 examples, because there's going to be problems like this on your homework, so I want to make sure you understand how to do these. And we're going to actually start with my 1, 2, and 3 down below, and then go back to the word problem as our last one. Okay, so for example, on number 1, if we are trying to figure out what x is, not x squared, but we want to know what is x, we have to figure out what squared is 100. Now this one you might be able to do in your head, but I still want you to show how to do it because the equations will get more complicated. And the way that we undo that x squared is to take the square root. because the square root of x squared is x. And we know with equations that whatever we do to one side, we have to do to the other side to keep it balanced. So we have to take the square root of 100, and that's 10. Again, technically it could be plus or minus 10, but unless it specifically asks you for both roots, you can just give the positive. Okay, now look at number 2. This one got slightly more complicated, but we're really just applying what we already know about equations. Okay, so my goal is to get x by itself. So I've got to move things away from the x. So I have a minus 4, so the first thing I'm going to do is add 4. That gives me x squared equals 49, because again, I have to add 4 to both sides. And now I don't want x squared, I just want x. So to undo that square, I'm going to take the square root. Whatever I do to one side, I have to do to the other. And the square root of 49 would be 7. Now, I am not going to make you go through and do a check step on these, but you might want to do a quick one in your head to see that this works. Let me show you. Do you understand that if you plugged in 7 and did 7 squared minus 4, it would give you 45, because 7 squared is 49, and 49 minus 4 is 45. Again, you do not have to do the check step, but not a bad idea to maybe do a little one in your head. All right, last one in this set, number 3. We have 3x squared equals 108. So I want to get the x by itself. What operation's happening between the 3 and the x squared? Well, it's multiplication, so I'm going to start by undoing it with division. I'm going to divide each side by 3. That gives me x squared equals 36. You're welcome to use your calculators to make that division easier. And then I don't want x squared, I just want x, so I need to take the square root of each side, because the square root of x squared is x, and the square root of 36 is 6. So my answer is x equals 6. And again, you don't have to do a check step, but you could to make sure that that is the number that would give you a true statement. This would be 3 times, in this case, 6 squared. And because order of operations, you do exponents first, so 6 squared would be 36, and 3 times 36 would be 108. So you see that that would give you a true statement. All right, let's do the last word problem. An amusement park ride includes a free fall drop of 272 feet. You can use the equation d equals 16t squared to determine the time t in seconds that it takes a dropped object to fall a distance of d feet. So how long does the free fall part of the ride take? Well, if this is our equation, d equals 16t squared, and the distance is 272, we're going to solve this just like we did these previous ones. So right now I want to get t by itself. So I first need to get rid of that 16. It's 16 times t squared, so I'm going to undo that multiplication with division. So I'm just going to make it easy, type into my calculator 272 divided by 16, and that is 17 equals t squared. I don't want t squared, I just want t, so I'm going to take the square root of both sides. Now, I know right away that 17 is not a perfect square, so when I take the square root of 17, I am going to get a decimal, and that's fine. Just remember to always round to the nearest hundredth, so I would get 4.12, and then it's a word problem, so I do need feet. Okay, well, I'm trying to find time in seconds, so it would be 4.12 seconds. You solve them just the same way we did the ones below. All right, I know that was a little bit longer lesson than normal. We had a lot to cover because we talked about what a square root is and expressions and equations. But since we needed to kind of lay the foundation, this video was a little bit longer than the other ones will be. All right, you can move on to your homework now. I hope you have a fabulous day.